Hello everyone, this is Devansh Sinha from Team Graduate Yourself. I'll be teaching geography on this channel, and today I am here to discuss a very crucial topic of physical geography, that is plate tectonics. I am pursuing my graduation from University of Allahabad, and this is my first video on this channel. As we all are in a lockdown, so I thought to make some videos for the students who are stuck at various places. I hope it will serve the purpose. As far as the plate tectonics is concerned, it is the most important topic of physical geography, especially when it comes to the graduation students of first as well as third year. So, without wasting any more time, let's get the ball rolling. Before moving on to the plate tectonic theory, I believe that there are certain elements which we need to understand associated with the plate tectonic theory, that are the terms such as plates and the plate tectonics, continental drift, sea floor spreading, etc. So, before understanding the plate tectonic theory, let us know what are plates. The lithospheric slabs or rigid and solid crustal layers are technically called plates. So, what the plates are nothing more than the crystal layers, the solid, hard crystal layers of the earth, which we see, which on which we are standing, on which we build our civilization. This is known as the plates. It is also known as the lithospheric slabs because it's part of lithosphere. The whole mechanism of the evolution, nature, and motion of the plates and resultant reaction is called the plate tectonics. So the plate tectonics is combinedly evolution, origin, nature, and the motion of the plates, and its resultant reaction or effects is known as the plate tectonics. Developed from the 1950s through the 1970s, plate tectonics is the modern version of the continental drift theory, which was propounded by Sir Alfred Wegener. Okay, so the plate tectonic theory is nothing more than a very advanced or a modern version, or again a recreated version of the continental drift theory, which has already been propounded by Sir Alfred Wegener. I expect that you must be having a little idea about what exactly is the continental drift theory. Maybe we can discuss it somewhere later. So, moving further, the theory is based on the two major scientific concepts, that is, first, the continental drift and sea floor spreading. So, the entire theory is standing on these two pillars of the continental drift and sea floor spreading. Right below this, a diagrammatic representation has been given which represent the main aspects of the plate tectonics. As you can see, the here over here the oceanic plate and the continental plate has been shown, as well as the various tectonics landforms associated with it. Physical reliefs have are also been shown, such as transform fault, trench, mid-oceanic ridges, as well as the subduction zone. So you can also have a look towards it. Moving on, there are 6 major and 20 minor plates which have been identified so far. What are those 6 major plates? It is the Eurasian plate, which is a combined plate of Europe and Asia. Second is the Indo-Australian plate. Again, it's a combined landmass of the India as well as Australia. Third is American plate. Fourth is Pacific plate. Fifth is African plate, and sixth is the Antarctic plate. So over here a diagrammatic representation is being given. You can clearly see the 6 major plates, and you can also locate the 20 minor plates. So the tectonic plate boundaries or the plate margins are the most important because all tectonic activities occur along the plate margins. Okay, so over here it has been said that the plate margins, it is the most important of the tectonic activities because all the tectonic activities associated with the plate margins, such as the seismic events, earthquakes, volcanicity, mountain building, faulting, fracturing, etc., all occur along it. Okay, plate margins are generally divided into the three groups as follows. First is the constructive plate margins, which is also known as the divergent plate margins or accreting plate margins. Now, what is constructive plate margins? So, it is nothing but these are the boundaries, or these are the margins which represent the zones of divergence. Means when the plate move apart from each other or diverge from each other, then the zone is represented by the constructive plate margins or divergence, due to which there is a continuous upwelling of the molten material lava from the crust, and this the continuous oceanic crust is formed. In fact, the ocean plates split apart along the mid-oceanic ridges and move in opposite direction. So this is the constructive plate margin. Second is the destructive plate margins, is also known as the consuming plate margins or the convergent plate margins. Convergent plate margins are when the occurs when the two plates move towards each other. Means when the two plates converge, it comes towards each other in this, okay, in the they are coming along the same line in the opposite direction. It means then the plate margin will be said as the convergent or destructive plate margins. Generally, in this case, it has been seen that the one plate overrides the other plate, and the plate is and the overridden plate is subducted or thrust into the mantle, and thus the part of a crust is lost in the mantle. Third is the conservative plate margins. It is also known as the shear plate margins. I'm sorry I have not mentioned it here, but is also known as a shear plate margins. Here two plates pass or slide past one another along transform faults, and thus the crust is neither created nor destroyed. Here the plates cross each other parallel, and neither it is been created and nothing is destroyed over here. So here a diagrammatic representation is being given. You can see the divergence and convergence of the plate and associated phenomena as well as associated factors. There has been subduction shown over here, and the sea floor spreading, formation of the mid-oceanic ridge, trench and rift has also been shown here. So you can look towards the diagram. Professor H has postulated the concept of the plate tectonics in 1960 in support of continental drift. It says that the continents and ocean moves with the movement of these plates. Okay, so Professor Hess has postulated the concept of plate tectonics in the support of continental drift. It means that plate tectonics was developed or was being propounded with the support of or with the help of the base, which is the continental drift. It was generally said that the continents and ocean move with the movement of these plates. It means that when the plates are moving, the continents and oceans also moves with these plates. Plate tectonic theory is based on the evidences of the seafloor spreading and paleomagnetism. Paleomagnetism is nothing more than the magnetism which is being found in the rocks of the earth due to the magnetic forces or the magnetism of the earth. Okay, so now let us understand what is exactly the sea floor spreading. This concept was propounded by Professor Harry Hess. Okay, so Harry has propounded that the mid-oceanic ridges were situated on the rising thermal convection currents coming up from the mantle. Okay, so over here the Professor Hess is saying that the mid-oceanic ridges are situated along the line of the thermal convection current. Means it is situated on the line of the thermal convection current coming up from the mantle. Since it is coming up, which is the thermal convection current which is found inside the earth crust, okay, which is responsible for the movement of the particles inside the earth. Okay, so it generally comes up from the mantle, so the mid oceanic ridges are situated along it. Okay, now the oceanic crust moves in opposite direction from the mid-oceanic ridge, and thus there is a currently continuous upwelling of the new molten materials along the mid-oceanic ridges. Again, when the oceanic crusts move in opposite direction, there is a formation of the mid-oceanic ridge, and along the line of the mid-oceanic ridge, there is a continuous upwelling, means outpouring of a new molten materials. It could be magma, it could be lava along the mid-oceanic ridges because of the movement of the plates in the opposite direction. Now, these molten lavas cool down and solidify to form a new crust along the trailing ends of divergent plates. Okay, now when the malva when the lava comes out, it cool down and gets solidify to form a new crust. Here the new crust formation is taking place along the trailing ends of divergent plates, okay, over the ends of the plate which got diverged. Moving further, thus there is a continuous creation of the new crust along the oceanic mid-oceanic ridges. So with the same process, a new crust is always being formed along the mid-oceanic ridges. Now, this proves the fact that the sea floor spreads along the mid-oceanic ridges and the expanding crust are destroyed along the oceanic trenches. These facts prove that the continents and ocean basin are in constant motion. Now, over here, the professor has justified and has proved that because of the above mentioned fact, which is because of the seafloor spreading along the mid-oceanic ridge and the continuous expansion of the crust, it causes the movement of the continents and an ocean basin. Moving further, the plate tectonics and the continental displacement. Okay, so though the sequence of the events of the continental displacement based on the evidences of the paleomagnetism and sea floor spreading is available only for the last 200 million years, but on the basis of the general mechanism of the plate tectonics and the evidence from the continents, the sequence of the early events may be reconstructed. Over here, it has been said that the sequence of the continental displacement of the proof or the evidences of the paleomagnetism, sea floor spreading, and the continental displacement has been witnessed only for last 200 million years ago, but the process is age old. It could be, the 700 million years ago or from the time immemorial. So over here it has been said that the same process must has been existed, and the scene can be recreated in the form of that the plate tectonics and the evidence from the continents and the sequence of the early events may be reconstructed. Okay, moving further, the okay, over here a diagrammatic representation has been shown. It will increase the visibility of my explanation. Okay, so you can see this over here, a Precambrian period has been shown. Precambrian, Caledonian, Hercynian, these are basically the periods in our geological clock. Maybe someday another or some other day we will discuss about the geological clock, that is era, epochs and periods. So the same is given over here, that is a Precambrian period. There was a united landmass which was a supercontinent known as a Pangaea 1. It got disrupted after many years, and when it got disrupted, there was the formation of the Caledonian mountains in the Caledonian period. They formed the Hercynian mountains in the Hercynian period, and again this disrupted plates got again united in the form of the Pangaea 2, and now this cycle again move on. Pangaea 2 again got disrupted, broke, and it forms the present day continents and the ocean basin. Okay, so the picture becomes very clear over here how this works. I know, I think that till now I have given you the exact idea of what is the plate tectonics, and I am successful in it, I will hope. So before coming to the evaluation of this, there's a diagram given over here, you can see, which shows the arrangement of the continents and the ocean basins from the Triassic period till now in the 6 stages. You can see earlier in the first stage, North America, Eurasia, South America, Africa, Australia, and Antarctica were united as a single landmass. Gradually, with the passage of time, they got disrupted, moved away from each other, the plates moved, and the present day arrangement of the oceans as well as continents is achieved in the sixth figure. So now moving towards the evaluation of this theory, it is commonly agreed by the majority of the scientists that the plate tectonics has validated the concept of the continental rift. Even I accepted that plate tectonics was mostly successful in establishing the and validating the concept of the continental rift. We are aware of this concept. Rather, continental drift has now become a reality. Yeah, it is. The only point of the argument in question related to the competent force responsible for drifting of the continents. Yes, the question arises that what force is actually responsible for, disrupting the continent and displacing the continent at such a large extent. This is definitely a very important question. Now, most of the scientists still rely on the thermal convective currents coming out from the mantle as the probable adequate force to move the plates in different directions. So the most of the scientists they are saying the fact that the thermal convective currents which is present inside the crust of the earth or in the mantle, this is the probable adequate force which is responsible for displacing the continents and which is responsible for the movement of the plates in the different direction. So this was all regarding the plate tectonics theory. As you all know that this is my first video. I know there would have been a lot of mistakes in this video, so kindly pardon me, and the feedback is always welcome. You can tell me in the comment section, as well as whatever topic you think that I should make video on it. Whatever is your demand, you can also tell me in the comment section. Till then, thank you so much for watching this video and keep supporting. Thank you so much.